the formula is AN equals A1 plus parentheses n minus 1 times D. So first thing we're going to do is identify the A, N, and D values. We're finding the 14th term. So first of all, the N is 14. The A1 is the first term. That's 2. That's the first term in the sequence. And the D is how much the numbers are changing. These numbers are going up by 3. And so you can see that even 5 to 8, 8 to 11, it's going up by 3. So these are the numbers that we're going to then take and plug into our formula over here. The formula, once everything's plugged in, should look like this. A14, the 14th term of the sequence, is equal to A1, which is 2, plus N, which is 14, minus 1, times D, which is 3. You can type that all in, or you can just work it out by hand. We're going to get 2 plus 13 times 3. If I keep working that out, I'm going to get 2 plus 39. And so the final answer would be that 41 is the 14th term of that sequence. So notice how everything's working. I'm first identifying these important terms. I'm identifying the N, which is the number here. That's N. I'm identifying the A1, which is right here. And I'm identifying the D, which is how much it increases between each number. I'm going to do one where it's subtraction, so I'm actually going to skip the second problem and move down to the bottom. In this problem, the A1 term is 10. It's the first term. The D, or the N value, is that we're finding the 11th term. It's here. There's my A1. There's my A1 right there. There's my N right there. And the D is how much it's increasing, or in this case, decreasing. This one is going down by 6. 10 to 4 is down 6. Down 6 to get to negative 2. Down 6 more to negative 8. So those are my values right there. I'm going to come over to my formula. I'm going to plug everything in. I get A11 equals 10, which is A1, plus 11 minus 1, which is the N value minus 1, times negative 6. Working out to the next step, I get 10 plus, again, 10 inside the parentheses, times negative 6. 10 plus 10 times negative 6 is negative 60. Sorry about that. Let me erase this real quick, everybody. Sorry about that. It's popping up on me. Negative 60. 10 plus negative 60 is negative 50, and that is the 11th term of that sequence. So you just need to make sure you have your formula in front of you. Again, this is coming from the formula chart, which I gave you, and you have a copy of, and you're going to be using that formula there. All right, let's keep moving. The next one is going to deal with direct and inverse variation. Again, looking back at our formula chart, direct and inverse variation are the next two things on your formula chart. The ones we're going to use are going to be the ones on the rightmost edge most of the time, but we're also going to be using the middle one as well, because on this first set of problems, we want to know if they are inverse or direct variation. So just as a reminder, inverse variation is where the the pairs of values are multiplied by each other and they remain the same. Whereas direct is when they're divided by each other and they stay the same. So if I wanted to see if this group of numbers was direct variation, I would just divide each of them. So I'd do 20 divided by 1, 10 divided by 2, and 5 divided by 4. And I want to know if I get the same answer when I do that. And I don't. I get these are my three values, 20, 5, and 1.25. That tells me right there that it is not direct variation because these numbers don't match. So then I would want to go check for inverse variation. Inverse variation says that when I multiply those numbers, I should get the same result. 1 times 20 is 20, 2 times 10 is 20, and 4 times 5 is 20. Because those are all the same, then I can say it is inverse variation, not direct. Looking at the next one, same idea. So I'm checking to see if this is inverse or direct variation. So I'll start by doing 15 divided by 5, 21 divided by 7, and 27 divided by 9. That gives me 3, that gives me 3, that gives me 3. And so then that means this is direct because it checked out. They were all the same result. That's what you're looking for. So again, direct is coming from the fact that this is my formula for direct variation. That's why this one was direct. And this one is why it was inverse, because that was the one that worked out for the first group. The next section is going to utilize the other formula for direct or inverse variation, which is the one where you actually solve problems. So I'll do two examples here. For the inverse variation, we're going to use the formula where we have xy equals xy. Get that up on the screen. So we're going to do xy equals xy. So we're going to do xy, and the first one is going to be this xy right here. So we're going to do 7 times 10. And then the second xy is going to be this group of numbers. We don't know what y is, so we're just going to do 2 times y. And when I work that out, I end up with 7 times 10 is 70 equals 2y. And then I'm just using algebra to solve. We've done this 100 times. Divide both sides by 2. Y equals 70 divided by 2 is 35. And so that would be the value of y in that situation. So that's for inverse variation. That inverse variation formula is coming from your formula chart under inverse variation. In my next problem, I'm going to look at direct variation. Direct variation formula is y divided by x equals y divided by x. So I'm going to put things in this formula, and it's going to look like this. This is my first group, 45 divided by 3 equals, and then I have x and 135, so I'm going to put 135 here over x, and then I'm going to cross multiply to solve. So when I cross multiply, I end up with 45x equals 135 times 3. 135 times 3 is 405. Then again, I'm just doing basic algebra, solving by dividing both sides by 45. I get x equals 9. And that is the value for the situation provided there. And again, direct variation is the reason I knew to use that formula, which comes from your formula chart. Almost there. The next section is going to deal with slope. Oh, by the way, there are two more problems for direct and inverse variation for you to try out. Looking at the slope, we'll start with the formula. Once again, the formula chart is going to show you where to find that. Your formula chart at the bottom, you're going to be looking at the rise over run or the y2 minus y1 formula over here in the bottom right-hand corner. That's this one right here. So looking at that, let's hop over to our formula. I'm going to write this formula down here at the bottom. The formula that we're using, again, is the slope, which is usually represented by the letter m, is equal to y2 minus y1 divided by x2 minus x1. So looking at my first problem, this is my x1, y1 numbers. This is my x2, y2 numbers. And so when I go to plug those all in, I'm going to come over here, and my y2 is going to come first from the top. It's going to be 3 minus 1. That's the y2 minus the y1. And in the bottom of the fraction, we're going to get x2, which is 5, minus x1, which is 2. 3 minus 1 is 2. 5 minus 2 is 3. And so we end up with 2/3 as our result. I'm going to go ahead and do this second example to show you one where we have some negatives. So we have, again, x1, y1, x2, y2. So then looking at these, I can see that I have my y's here and here. So I'm going to do -6 minus -1. You'll notice I wrote it all out because I want to be careful about my negatives. And then my next one is going to be -2 minus 1. -2 minus 1. So then we're just going to work that out. Feel free to rely on your calculator for this if you need to. But -6 minus 1 is the same as -6 plus 1. So that's going to be -5. And then -2 minus 1 is -3. Now you'll notice that's not quite a great answer because we see we have negatives in both. So I think the best way to write our final answer is to say we have 5/3 without any negatives. So you can go ahead and cancel out negatives like that if you end up with a negative in both. Otherwise, the whole answer is negative. Leave those rest of those for you to do. Now we're going to look at the graph version of that. The graph version of this looks like this. I'm going to go ahead and highlight the points that we're looking at. We've got a point right here and a point right here. And we're going to count the rise over run. So the rise is 1, 2, 3, 4. It goes up 4. Remember to always check yourself. This is a positive slope because it's going up from left to right. So we're going to keep that in mind. And then the run is going to be over 1, 2 over 2. So 4 over 2 is your answer. You could reduce that, but you don't need to. That's pretty much it for this whole page. So for the negative ones, let's look at one where there's a negative number. So here's my points. I have a point here and a point here on the graph. And I'm going to go down 1, 2, 3, 4, 5. Down 5. Because it's a negative. I can tell it's negative right away by looking at it. Over 1, 2, 3, 4, over 4. And that would be my answer, -5 over 4. That's pretty much it. You're just counting the number of spaces from one point to the next point, always moving from left to right. And remember that the up or down part of the slope is what tells you whether it's positive or negative in our answer. Also, you should be able to tell just by looking, like we talked about in class. Lastly, this was the 4 diagrams that I gave you in the notes. You need to be able to draw simple slope diagrams to represent, not draw, but be able to identify, I guess is a better way of putting it, to identify positive, negative, 0, and undefined. Those are the 4 types. So I'll draw just an example of what could be the right answer. Positive slopes go up from left to right. Negative slopes go down from left to right. 0 slopes go directly across the page horizontally. And undefined slopes go straight up and down across the page. That one doesn't look quite right, so maybe I should erase that and be a little bit more careful with my drawing. Yeah, let me erase that. So undefined slope should be straight up and down. That's pretty good. That's better. So this is what you need to know. Right here, what you see on the screen is what you should be studying and know, and you have in your notes. So make sure you're looking over that before you take the test. So just a reminder, the things that you get on the test in particular is going to be the most important thing you want to know is you get this formula chart here. That should be something you rely on pretty heavily. But besides that, you need to know how to determine if things are functions, linear functions, and all that good stuff on the first part of the test. Other than that, that's all I have to say for this review. Just make sure you're studying. Good luck.